Alright, so we're looking at rearranging formula, and these are just called complex because it's just it involves everything we've done up to now and a little bit more. So, there's no real one method fits all for these. You just kind of have to do what we did before and think, okay, I've got to separate these. Now I might have to take a square root or square something, expand brackets, factorize, combination of all those simplifying techniques. So here we're making u the subject, so we want to leave u on this side. I'm going to subtract off 2ad, so I subtract off 2ad. Rewriting that, that's going to leave me with v squared minus 2ad on our left, and on our right we have u squared. Now I have to think, what's the opposite to squaring something? Well, we square root it. So we square root this entire side, so we're left with just u is equal to square root of v squared minus 2ad. Most common misconception is not writing the square root over the whole function. Okay, so here, next one, we're looking for y squared. So we have a y squared here and here. That tells me I have to expand that bracket first off. So right away, I can write x squared plus 4y squared equals z squared plus 2y squared z squared. Now I'm going to move everything with a y to the left and everything else to the right. So by doing that, I have to do minus x squared on our left side, so I have to subtract it on our right side. Then I have to subtract this 2y squared z squared, so I subtract 2y squared z squared from our left. Let's rewrite it. So we have 4y squared minus 2y squared z squared. And that's going to be equal to z squared minus x squared. You can check, well, we've got no y's on the right, so we're doing good. So here, let's now factor out a y squared, because I see a y squared in each term, so I can do y squared is bracket, and factoring actually will save you a lot of work sometimes, or actually be able to make it so you can do something. 2z squared on the inside equals z squared minus x squared. So we can divide both sides by what's in our bracket. I'm actually just going to rewrite this over here just to make sure we have enough room. Y squared equals z squared minus x squared over 4 minus 2z squared. And now to get just y squared, we take the square root of both sides. So I'm actually just going to do that. And that'll result in just y. Last one, and this one's going to look very awkward. What the heck's going on here? This is not what we're thinking of normally. So let's try and make sense of what is going on. So we want to get all of our signs to one side. Okay, so here, here, how do we do that? Okay, let's go subtract this x, or sine x, right? Subtract the whole thing, it doesn't matter just because it's changed. And then here we subtract 5, so we subtract 5. Okay, so here we're going to get 2 sine squared, I'm just bringing that squared inside, sine squared x cos y minus sine x is equal to negative 5. Okay, I see is this actually going to work? I actually have a feeling this isn't going to work, so I'm just going to get rid of this squared on this term right here. I don't think that's actually going to work. So here we can go 2, or sorry, now we want to factor out a sine, because that wouldn't have worked. So sine x, we're going to leave on the inside cos y minus 1. So divide both sides by cos of y minus 1. So divide by, I'm going to copy down that negative 5 after, because I had forgotten to before. So on the left-hand side, we're going to be left with just sine of x, and I forgot that 2, sorry, is equal to negative 5 over cos y minus 1. And then, well, if we do the sine of a function, well, to do the opposite, to get just x back, we have to do inverse sine. So just like I said, inverse to addition is subtraction. Addition is subtraction, multiplication, division, squaring is square rooting, same as sine and sine inverse. Opposites, we'll get the same thing back. So here we're left with just x equals sine inverse of negative 5 divided by cos of y minus 1. Just to show you that it does not matter, even if we don't have no idea what the variables are, even if we have no idea what these are, if you haven't done trigonometry yet, or still confused about trigonometry, it doesn't matter, because we just had to rearrange it. So you just have to know what is the opposite operation to doing something. And while that it may look scary, and you may never see something like this, just if you could do this, that means you can rearrange for anything.